Cool It, a math experiment on exponential decay. This is an experiment we did in math class to help us have a better understanding on exponential decay. For our experiment, we used the following materials: a boiling water jug, a cup, a temperature probe, a CBL, and a calculator. What we did first is we poured the boiling water into the cup. After we poured the boiling water into the cup, we put the temperature probe in. Then we turned on the CBL, and then the calculator began recording the temperature of the water inside the cup for every 60 seconds for 45 minutes total. How to find the decay rate and the initial condition using a table and a graph. To find the initial condition using a graph, look for the y-intercept. In this graph, the y-intercept is 191.51. This is your initial condition. Using a table, the initial condition is right here, 191.51. Now, to find the decay rate using a table, you can divide the second number, 150.2, by the first number, 191.51. To get more of a precise decay rate, you could divide the fourth number, 124.35, by the third number, 134.66. The answer will give you your decay rate. The answer I got for my decay rate was 0.978. Now, to using a graph, you can also find the decay rate. Look for two consecutive numbers, for example, A and B, and divide the second one, B, by A. So B, which is 150.2, by A, which is 191.51. The answer will give you your decay rate. Just like we did using the table, we can also find more of a precise decay rate. So you could divide D by C. This is how you find the decay rate using a table and a graph. What is the initial condition and the decay rate when you have the equation? This is the initial condition, 191.51, and this is the decay rate, 0.978. Data for water temperature differences. How are the temperature differences significant in the problem, and what question would the data answer? The data is shown in three different ways. This is the table, this is the graph, and this is the equation. The data of water temperature differences are important in this problem because it can help you find the difference of the temperature of boiling water and room temperature at any given point during the experiment. This is what the data shows. What question would the data answer? Well, for example, if you wanted to find out how long it would take for the boiling water to cool down to room temperature, then you could use this data to answer your question. The data shows the difference of the temperature of the boiling water and room temperature at each 5-minute interval. So using the graph, you can look for the point when the water temperature difference has a temperature of 0 compared to room temperature. When I look at my graph, the water temperature difference has not yet reached 0 because we conducted the experiment for only 45 minutes. Using the graph to predict when the boiling water would reach room temperature, I would say it would take around 55 minutes total. If we conducted the experiment for a longer period of time, then we would be able to tell the exact amount of time it would take for the difference to be 0. In this experiment, we basically took boiling water and we found the rate at which it decays at, the temperature decays at. And we also put this information in a graph and a table, and we used this to put it in an equation form also. And we also found the temperature differences too between the temperatures and the room temperature. I learned how to find the decay rate using a table, graph, and equation. I also have a better understanding of the differences between exponential growth and exponential decay. I also know how to find the rate and factor for both exponential growth and exponential decay. I also learned the differences between a linear and exponential pattern through this experiment.